any kind of digital transformation and automated digital lab, there's always going to be a cost to that. Understanding the ROI or making sure that leadership within the organizations are very clear about that. This is a longer play. It's not something that will be in the short term. This is a commitment.
Welcome back to part 2 with David Hardy from Thermo Fisher Scientific. In part 1, we mapped the connectivity problem, where fragmentation hurts most and what holds automation projects back. Now we turn to what actually works, what a connected lab looks like in practice, the shortcuts teams regret, and what good data governance looks like day to day, and where AI fits once the foundational work is done. Let's get into it. Are you juggling the complexities of CMC development while trying to enjoy the beauty of biotech? Have you ever wondered if there's a way to simplify bioprocessing? Welcome to the Smart Biotech Scientist podcast, where we're diving headfirst into the very challenges you face. We're breaking it down, demystifying the jargon, and giving you the keys to unlock your full potential. I'm your host, David Brühlmann, and I get it. With 15 plus years in the biotech industry, I face the same challenges you do. There's a way to simplify and streamline so you can remove complexity, you can skip trials and errors, deliver without delay your groundbreaking therapy to clinics and market, and still enjoy every single step. Do you want to learn how industry experts and I did it? Grab a cup of coffee and your favorite notebook and pen. Now is the time to take your bioprocessing game to the next level. Let's smarten up biotech. Before moving into AI, I would like to touch upon automation. You mentioned it because this is also part of data connectivity. There's a lot of effort on automation, especially analytical side, but also on other areas in bioprocessing, such as cell line development or screening. What are some of the bottlenecks you have come across in automation projects?
So bottlenecks around the data really stem from the sheer volume. Going down an automated approach for your kind of lab, your kind of bioprocessing, it's just the sheer volume of it. They're going to be working 24/7. So really, that's when the approach that you've taken really has to scale. You know, the data that's produced, I'm sure that'll be the same as what you've been doing before, but it'll just be on a much larger scale. And then on top of that, you may also have things like log information coming out of the automation. But this in itself is, again, useful. Running instruments that create data, and then the process of running them creates data as well. That is also of huge use for optimization of the lab, ensuring that the lab is running and the bioprocess is running efficiently. We're back at this exponential curve again, where it's just compiling the data volume, if you like.
So it's mostly around the quantity of data. That's the biggest bottleneck around automation, correct?
I think so, because we're not automating something that's drastically new. They would have piloted, maybe at a smaller scale, that kind of process. The data output will be very similar. Obviously, as they scale with automation, then there might be some kind of changes with the equipment. So we're back at the ability to adapt. But in essence, processes they're carrying out are going to be largely very similar.
Now, moving on to AI, many people are excited about AI, no doubt about that. The question is always whether AI and machine learning delivers, whether it really makes a difference, and how do we integrate that? What do you think separates organizations from those who are able to extract real value from AI and machine learning from those who are still waiting for to deliver?
It's interesting that you phrase it as machine learning, because everyone these days, you mention AI and everyone immediately thinks, oh, we're talking generative AI. But the traditional ML, the predictive AI, so to speak, is still the backbone of AI. Gives you, obviously, that's where you need, in particular, the data volumes, depending on the AI model you're using. But that will give you a much better quality value, maybe a category or something along those lines. But then we're back at the data quality, the data volume, in order to train those models, in order to perform that analysis. And then going back, it's kind of, had we anticipated the question that we want that predictive AI, the ML, to actually provide an answer? It's very cyclical and a fully intertwined process.
And what do you think is important to make the best use of AI, also not knowing where it's heading or perhaps trying or to play around with some new features? But what do you think is the right way to approach that?
Traditional kind of ML, those models require that data to train a model. Then the data quality has to be good. So you really need to put something in place to check that quality as that kind of data is being ingested. And going back to the question was, how do you know what data you need in order to create the model, to run the model, etc.? Then again, we're back in the chicken and egg scenario. Sometimes you might have acquired data over a couple of years for a particular process, and then someone thinks, actually, we could simplify this by using some AI, maybe running fewer tests by making predictions on certain key results, etc. But that might then involve going back to the original data and maybe kind of re-extracting certain parameters that or values that may not have been captured at the time. And I think that's pretty normal, and that's been the data scientists and the data wrangler. They've been doing that for years already. You can never predict fully the future questions that might come up that then relate back to what values, what results do we need in order to train this model and answer that kind of business question.
So what I'm hearing, David, is that the value around machine learning is much clearer than it would be with generative AI because the model are better understood. And as long as you have good data, you are very likely to get something good out of it.
Yeah, it is just due to the nature of the fundamentally algebraic equations, ultimately, that are under the hood. The predictive AI should, given the same inputs, should give you exactly the same output. Generative AI is probabilistic, so that may kind of vary. The ML, the predictive AI, deterministic, there's still a lot of merit in doing that. And then, obviously, you need the data in order to do that. But not everything is Gen AI.
I would love to have your view on the ideal future in a couple of years or in 5 years. How does this fully connected AI-enabled lab look like to you?
I think the full AI-enabled lab, what does that look like? I think obviously AI is going to have a huge impact in terms of the tools, the processes that are carried out in the lab by the users, by the scientists, the people running the instruments. I think everyone's in agreement that things like predictive maintenance, the ability to, for instance, to run, to and kind of self-diagnose kind of problems and flag issues early to users. I think that's all a bit of, everyone's been talking about that for a long time, and that's kind of a bit of a given. I think going back to some of the topics that we've discussed today, I think there's also the role of using AI to potentially go back, reevaluate that kind of data and to do the quality checks, etc., and to bring this extra kind of data in. I think the stuff that we all talk about, but then there's all this kind of peripheral stuff that just really enables the kind of day-to-day processes and uses of AI to make that even easier. That's the power and the excitement that AI brings into the lab.
According to you, are we far away from a fully connected lab or not?
No, I don't think we are. Thermo Fisher Scientific, for example, we have several customer experience centers around the world where customers can come in and see that lab today. I mean, it's evolving, but the end-to-end from the let's have a thought, an idea, a hypothesis, probably a better scientific term, through to taking that to kind of running it an automation system and then generating results from that and then feeding back into that kind of pool of information and knowledge, all contextualized with all the right metadata. So that can then help with the next round of experiments, the next hypothesis kind of question. That's something that we can very much do today and demonstrate. Really exciting.
Coming back to the data, in order to have such a connectivity and to tap into the full potential of AI, we need good data governance. What are the main pillars of good data governance?
Data governance is key. And actually, there's two kind of schools of thought here. Obviously, we want good quality data is key. You can't get anywhere with garbage in, garbage out analogy. But then in terms of governance within organizations, there's definitely two trains of thought in terms of Yes, we need to make sure that certain users can access this data, that it's not used to train LLMs and the wrong people can kind of see it, etc. That's been there for years, and with things like audit trails for access and the data and stuff, that's been there for years. An interesting one is this notion of actually, let's democratize data. Let's just say, if you're within an organization, then what are we hiding? Let's just make sure that that data is available for the whole organization to use. You then get into issues of people are then sensitive about their data and protective and all the rest of that. But there's kind of both schools of thought there. Going back, I mentioned a kind of, knowledge graph earlier, and that whole concept of that is around democratizing that data. It's always better to share, I would say.
So that means it's always better to share, always better to collaborate and have as many people working on that, right?
Yeah, I mean, it's very analogous to open source kind of projects, but within your organization. Just to clarify, there will be instances where certain data needs to be secure, and that will happen. But for large kind of chunks of data, then yes, why are you keeping it secret from your colleagues? The company has invested a lot of money in that data, both in terms of the people, the instruments, the reagents, etc. So should that data, that knowledge, that insight be available to everyone within the organization?
And it seems to me that brings us also back to the connectivity aspect. The better and the easier data is accessible, better we can use it and the more we get out of AI.
Yes. I mean, we're very much back at the data standardization. And that's where organizations like Allotrope, for example, their simple model, the ASM, works really well. And it's something that companies like Thermo try and output our kind of data and make it accessible at source in those types of formats. But there's a lot of work we can do. And then there's organizations like the Story Alliance, for example, who help create things like ontologies around certain types of data that, again, everyone can kind of use. But yes, the standardization is the key to enabling AI. If you don't standardize, then it's just an additional barrier that you need to overcome. But we like to keep things as simple and quick as possible.
David, as we are wrapping up, what additional question should I have asked? Or any aspect we should have covered or you think is important?
I think we've covered most things. I think any kind of digital transformation and automated digital lab, there's always going to be a cost to that. Understanding the ROI or making sure that leadership within the organizations are very clear about that. This is a longer play. It's not something that will be in the short term. This is a commitment.
Excellent. With all that we've covered today, David, what is the most important takeaway you want our listeners to walk away with?
The most important thing, and I think I've covered this several times, but we all know that good quality, standardized data is key to efficiencies within the lab, enabling you to kind of move faster, answer future questions, etc. But I think it's just going back to that commitment. This is not necessarily you do it once and then it's complete. This is a long journey. I think we've pretty much covered that quite a lot over the course of the conversation.
Excellent. So, smart biotech scientists, there you have it. Digital transformation is a long journey. You have to be committed and you have also to be able to adapt to the constantly changing technology. Thank you very much, David, for taking us into the world of digital transformation and connectivity. Where can people get a hold of you?
Sure. So I'm on LinkedIn, so you can find me there. Happy to take any questions. If people want to reach out, connect with me, then more than happy to answer any. Stay in touch.
Fantastic, David. Thank you so much for being on the show today and sharing about digital connectivity and digital transformation. Thank you so much.
Thank you, David. Thanks, everyone.
Connectivity isn't a technology problem waiting on better tools. It's a foundation problem that determines whether automation and AI deliver value or stall out. The labs making real progress are the ones doing the unglamorous integration work first. If this episode shifted how you think about that, please leave a review on Apple Podcasts or your favorite platform. Thank you so much for tuning in, and I'll see you next time. All right, smart scientists. That's all for today on the Smart Biotech Scientist podcast. Thank you for tuning in and joining us on your journey to bioprocess mastery. If you enjoyed this episode, please leave a review on Apple Podcasts or your favorite podcast platform. By doing so, we can empower more scientists like you. For additional bioprocessing tips, visit us at smartbiotechscientist.com. Stay tuned for more inspiring biotech insights in our next episode. Until then, let's continue to smarten up biotech.